Have you ever wondered how electric vehicles convert and control energy to power their motors? The answer lies in a crucial component, the inverter. Hello everyone, I'm Sean, an engineer specialized in electric vehicle development. An inverter is an essential part of the electric drivetrain, transforming the direct current DC from the battery into alternating current AC for the motors. Without it, the power that comes from the battery wouldn't be able to drive the motor efficiently. But how exactly does it work? Let's delve into the details. In an EV, the battery stores energy as DC, meaning the electrons flow in one direction. However, most electric motors run on AC, where the flow of electrons change direction periodically. The inverter's job is to flip the DC power into AC that can be used by the motor. As the inverter converts the energy, it also controls the frequency and the magnitude of the AC power, determining the motor's speed and torque. This allows for smooth acceleration and precise control of the vehicle. One of the greatest advantages of inverter is energy efficiency. With the right inverter, an EV can optimize power delivery, making sure the motor gets the exact energy it needs at any given moment. Inverters also play a role in regenerative braking, converting kinetic energy back into electricity during braking and feeding it back into the battery. This helps recharge the battery and improve overall efficiency, extending the vehicle's range. Now let's talk about the types of inverters commonly found in EVs. The most common are three-phase inverters. They are capable of handling higher power demands and are often used in larger EVs or in electric buses. Smaller EVs like those with lower power motors may use single-phase inverters. Three-phase inverters are more efficient for high-performance motors, while single-phase inverters tend to be simpler and cost less, but they are still very effective for standard EVs. Compared to traditional gas-powered vehicles, EVs with efficient inverters can convert a higher percentage of energy from battery into the usable power for the wheels. In gas vehicles, much of the energy from combustion is lost as heat. But with inverters, the electric motor is more efficient, sometimes reaching up to 90% energy efficiency, compared to just 20 to 30% in traditional engines. In addition to motor control, inverters also help the charging process. Some modern EVs use bidirectional inverters that allow energy to flow both ways, meaning your EV can also act as a power source, providing energy to your home or other vehicles when needed. But all this power conversion requires a lot of energy, and that's where cooling systems comes in. Inverters get hot when they operate, so they have cooling mechanisms, often using liquid or air cooling, to prevent overheating and ensure long-term performance. With proper maintenance, inverters can last the lifetime of the vehicle, but like any high-tech component, they can fail over time. Most EVs come with warranties covering the inverter, but they are generally built to last, making them a key player in the overall durability of an EV. So next time you are driving an electric vehicle, just remember the inverter is working behind the scenes, converting and optimizing energy flow to power your journey.